All right, so we're still in section 1.5. Now we're going to go down and look at example 3. Height of a projected object. I got to tell you, this is going to be one of the most common quadratic types of story problems that you're going to run into. So get used to dealing with height of a projected object. Let's talk first of all about what's important in this example and what's not important. So let's start reading. You have a projectile launched upward from the ground. That part is important. You need to know that maybe I'm throwing a ball in the air, or I'm shooting a rocket, or I'm firing a bullet. All of those things are going up into the air, and then gravity causes them to come back down. So that's an important part. It tells me that I have an initial velocity of 73.5 meters per second. In future classes, this is going to be an important part, but for this particular class, it's not going to be important because they're going to hand you this information inside of the equation. Also talking about neglecting air resistance, that's also not important for this particular class. It will be important though for future class periods. What is important is that you need to know that S is called height, and that S in this question is being measured in meters. The second thing that's going to be important here is that T is going to be measured in seconds. And then the third thing that's important is going to be the equation itself that they hand you. So you've got an equation and you have what each variable in the equation is standing for. So these things are going to be very important. So let's go ahead and read then what it's asking me. After how many seconds? All right, so the very first thing, just out of the first 4 words in the question, I know that I'm dealing with, hey, I want to know what my time is after how many seconds. So I know that I'm going to be solving for T. And then it tells me that I'm going to round to the nearest hundredth. So after how many seconds will the projectile be 100 meters above the ground? This is the second piece of information, and it's telling me that my S value, the height value, is going to be 100 meters above the ground. So then what we want to do is we want to take our S value and we want to plug it into the equation that we were handed. Just plug it in. Now what we're going to do is I'm going to teach you how to go through the calculator on this question. And I'm actually going to graph 2 different equations. I'm going to graph the horizontal line, y equals 100 meters. And then I'm also going to graph this side because this is the path that the ball or the rocket or whatever it is, this is the path that takes. And what I'm going to want to do is I want to see where these 2 overlap because I want to know when will the ball or the projectile be 100 meters above the ground. So I'm going to walk you through this pretty quickly. You may have to pause a good bit, but I've got some screenshots that I'm going to show you. So for the first thing, take your calculator out and you're going to go to y equals and you're going to type in your equations. And then you're going to go to the window next and go ahead and type in this window. Now, what you'll notice is that my X, min, and max, remember, these are my T's. So this is my time. I'm basically taking this projectile from -2 seconds, which cannot occur, all the way up to 20 seconds. And then I'm also looking, oh, sorry about that. I'm also looking at a y min and max, the height, the S value from -10, I think this was in meters, up to 300 meters. So this is the window that you'll want to put in. After you have after you've put your window in, go ahead and push the graph button. And this is what your calculator screen should look like. Now what we're going to do is we want to see where do these guys intersect. I know that my 100-meter line and my projectile intersect once here, but then they also intersect once here. I want to find both of these places. I have to do the same process twice to find these 2 spots. So I'm going to start out by doing second trace, and I want to go to where they intersect each other. So when I go to second trace and intersect, notice a couple of things. You're going to have your blinking cursor somewhere. Basically what you want to do is your blinking cursor needs to be close to your first intersection. So a couple things to point out on your calculator screen. At the top, it has the equation. Your blinking cursor should be moved close to the first intersection. So arrow left or right to get it close to the first intersection. And your calculator is asking you a question. It's asking you, is this the first curve that you want to look at? And so what you're going to do is you're going to push enter down here at the bottom to show, yes, this is my first curve. And then it's going to ask you, what's your second curve? Is this y equals 100? Is this your second curve? And you'll notice again that my blinking cursor is very close to that first intersection. All right, so then what we're going to do is push enter again when it asks me for the second curve. And then the last question my calculator asks me is, do you want to guess? And you really don't want to guess, so just go ahead and push enter. When you do that, your calculator is going to spit out the intersection. And so we're going to write this down for the question. So notice that the intersection is going to occur at the x value of 1.5131948. So what we're going to do is we're going to round to the nearest hundredth like the directions told me to, and we're going to go ahead and write down that particular solution. All right, so then what we're going to do is we're going to go back to second trace, and we're going to do the exact same method all over again. The difference now is that when you go to second trace, notice that you want to move your blinking cursor closer to the second intersection. So I'll give you a second. Go ahead and follow that first curve, second curve guess. And then what you'll notice is that you have an intersection, and now the intersection is over on the right side, and it's at 13.486805. When we when we round our decimal the way that it should be rounded, we're going to get 13.49 seconds. Now, a different question, how long is it going to take for the projectile to return to the ground? So our given information is the same, but now notice that what we want here is how long. So once again, I'm looking for a t value. I want to solve for t. How long is it going to take for the projectile to return to the ground? Let's go back and look at that graph. Essentially, I want when the ball is going to land on the ground. Well, what is the height when the ball lands on the ground? So we know that the height there is going to be 0. So let's plug 0 in for the height. I don't even need a calculator on this question because I have a GCF, and GCFs are really simple to work with. So the GCF is going to be a t. So let's factor out a t. And when I do that, I'm either going to have a t equals 0, or I'm going to have negative 4.9t plus 73.5 equals 0. So setting up my two mini equations. We don't care about the time equaling 0 because our question was how long will it take to return to the ground. So I don't care about the time equals 0 part. I care about the other part. So let's go ahead and solve our mini equation. We'll do this by adding 4.9t to both sides, and then we'll divide by 4.9. Sorry about that. We'll divide by 4.9 on both sides. And then just plug that number into the calculator, 73.5 divided by 4.9, and you'll get 15. And so the ball is going, or the projectile is going to return to the ground after 15 seconds.